All right, now, what we're going to do today is the following. First, we're going to start section 6.1. We could finish today. There's a possibility of finishing, getting through this whole section, but it might take us like a day and a half. Now, this is going to be the last topic that's going to be on your test next week. So write a little note that this is on the test on Tuesday, but section 6.2 is not going to be on the test on Tuesday. Again, 6.1 is today. We have class today, and we have class tomorrow. So we'll definitely get through 6.1 through today, and maybe tomorrow a little bit. So either way, it'll be on your test next week on Tuesday. The material that we do on Monday next week, which will be probably the beginning of section 6.2, will not be on your test on Tuesday. Okay? We can spend like 10 minutes at the end, maybe. Okay? About 10 minutes. But I mean, if I do that every time, we can lose a lot of days, and we don't have so many minutes. So what we're talking about today is momentum. Now, where have you heard the term momentum, or where could you say you've said, something about momentum before? Check.
On a bike.
On a bike?
Like when you're about to go uphill.
Okay, what do you say?
See, I need to get my momentum up so I can get speeded up so I can go up that hill a little bit easier.
So tell me what momentum is to you then.
I think it's...
How do you get your momentum up?
I think you have to do kind of a burst of speed or something, kind of like a
So gain velocity?
Yeah, gain velocity.
Okay, good. Gain velocity does gain momentum.
When I was like 8 years old, I played football, and I was trying to tackle somebody, and the momentum that I was running at, and they dodged it, carried me, and I broke my chin.
What did you hit instead?
A rock.
That's a very good example. Absolutely. He missed the tackle, momentum carried it forward, broke his chin. Or you see in football, good example of football, right? So you see all the time, you'll see running backs that are like, they only weigh like 250, barrel over linebackers, they weigh like 350. How do they do it? The one guy has less mass and people are not giving it over still. Yeah, the inertia of the object or its momentum. Now, so, let's focus. Let's make two comments. First, if you have more velocity, and more momentum. If you have more mass, you also have more momentum. Again, if you increase mass or if you increase velocity, you gain momentum. So what we're going to see on this next slide here is that our definition of momentum is simply the product of mass and velocity. Momentum is defined by a lowercase p, not a capital P. Garrett, focus, come on. Lowercase p is momentum and is defined as the product of the mass and the velocity. Okay, that's all it is. It's probably one of our easier formulas for the year. So all we're doing is multiplying two numbers. No squaring going on. There's no mg, mgy. What's that? I said easier formula. I said the last section. Easier math. Say again? Well, the one on courses I never said was going to be easy. I said the one on energy is easy. That's the coming test. Possible. Alright, so here's the thing. The units for momentum are just kg m over s. Kilogram from the mass, and then the units of velocity are meters per second. You leave it like that. There is no abbreviated unit. So if you want to write it like this, when you're doing your answers, you can write it like this as well. That's fine. And you can write your units. So the units of momentum are simply those units. There's no simplified unit like there was for energy. It was joules, right? There's no one unit that you're going to use to replace kg m over s. Any questions on this? It's a very simple definition because it's just simply a product, but we're going to look at examples and more applications of it. Now, before we get to that, here's what we want to do.
So momentum's going to be P.
I'm sorry?
Momentum's going to be P.
Lowercase p. Capital P was what? Power. Sure, we can go over the homework again. At the end, remind me we had about 5 minutes left. We'll take questions on the homework from last night. All right, so what we're going to do is the following. I'm going to look at now is this. Start with your equation, and we're going to come up with a brand new equation from this. So we're going to derive our second equation. That is our impulse momentum theory. Divide both sides by t. So start by dividing both sides by t. Next. What we're doing here, guys, is we're trying to come up with a new formula we're going to use, so we're going to derive it first. So if I divide by t, what is v over t? I heard it somewhere else. A. I heard A. Velocity over time is acceleration. So rewrite this formula now like this. So replace your v over t portion right here with the A right there. Now, we have delta, or we have P over T equals MA. What is MA defined as? The force, of the net force. Remember F equals MA? F equals MA. So replace this and write it like the following. And now, what I can say is this. Move the T up to this side. Take this T, move it up over here. So when I take that T value and move it up to the side of the equation, by multiplying both sides, I'm going to get momentum equals force times time. Momentum equals force times time. Now, the last thing we want to do is the following. Over a given time period, the object's velocity may change. So there might be a change in momentum. So really, the way this formula is written is the following. Change in momentum equals the force times the change in time. And this is really the way that your book gives it. I drop the delta in front of the t all the time. So when you see me write it on your formula sheet, you're going to see this. So that's what you're going to see me write your formula sheet right there. Because everybody knows by now that when you see a t, it means the time interval. Okay, I drop the delta. But generally speaking, don't drop the delta in front of the p, because that reminds you to do p final minus p initial. Remember, delta means change. So here it's going to be p final minus p initial. Brandon. Why what? Because, I'll explain. From the first formula here, if I can scroll up a little bit, from the first formula, I see a relationship between momentum, mass, and velocity. Now, if a problem gives you something with forces and a time period that a force is applied, you want to know how to utilize that. Well, you can do this every time and derive it. Or what we can do is simply do it once and have another formula in there. So any problem that gives you force, so I apply a force to this desk or this book over a certain time period, we can find the change in momentum, which might help us find the velocity of the object at the end.
Wait,
Okay.
what's the equation for velocity then for momentum?
I'm sorry?
How would, like, if you had momentum, then how would your velocity?
Go back to the beginning and look at the first equation. Momentum equals mass times velocity. So here, in this equation down here, if you wanted to actually do some math, you can write this as okay, because it's delta. P is represented by mv. We're going to do this in a minute anyway, so I'm just seeing it ahead of time. So you can use this formula right here, Max. Now, this is not a formula you're going to be given. I know the radiator's loud. Just trying to ignore it. I hear it. It's the radiator, so what is it?
It's raining.
Is it getting on you? Guys, the radiators just run water through. It's fine. It's just water. Now, this, stop the comments and focus. This formula is the one that we're going to use right here. We're going to use it a lot. But you're going to be given this formula down here. Delta P equals Ft. So you need to know that delta P is P final minus P initial. And then plug in for P for momentum, mv in both spots.
It would be the net force, not the
Always net force, yeah. So again, because this was Fa, I'm sorry, this is F equals Ma, this is the net force we're looking at every time. The net force. Okay? Yeah, that's right.
Isn't MV, so you're saying that CF is momentum right there, but then you're changing it in the same equation as the potential
Potential energy.
MV. Oh, that's 1/2.
1/2 mv squared is kinetic energy. That's different. But Jeff, I'm doing this. I'm taking mv right there.
Oh, yeah.
I'm plugging it in for P, but instead of putting mv, I'm putting mvf. Because it's pf. And mvi, because it's pi.
Pull it.
This just means the momentum at the end. So momentum is mv, but I'm going to use the velocity at the end.
Okay.
This is momentum in the beginning, I'm going to use the velocity from the beginning.
But then again, you don't really need that though because you're solving for the momentum.
But a lot of problems you're going to see today give you a relationship. They give you velocity sitting on it. They give you velocity, they might give you mass, and they might say find the time interval. So you need this equation there. Yeah. If you have the change in momentum, delta P, just plug it in and you're good to go. Fine. Start with a very basic example. Try this on your own, it's very basic, you're going to see that. The second one will be a little trickier. If you just look at your formula, you can all do this one.
By the way, this is my
Much more difficult problems?
Yeah.
Oh, bullet. Yeah. They said bulleted,
What does that mean?
like meaning several steps, like do A, B, C, D.
I have questions. Nothing wrong with that.
Yeah, some people still only 11 here. You might want to turn that in sooner than later. The people that still need to turn it in, the lab itself. Joe, you gave me yours, right, yesterday? Yeah. I put that on my computer, not the other. Gary, Max,
Max has his.
Yeah, dude.
that's it. Stasha got yours.
That's me.
So Gary, the last one. And then there was one, Gary.
Thank you.
And then what?
And then there was one.
And then there was
That's a good book. And then there was
And-
Would you recommend it?
to the whole class.
So, let's take a look at this problem now. We've got one object. By the way, let me just really quickly, I know you're writing this down, but just to clarify something on the last slide. This here, just so you know, I wanted to discuss this, I forgot to say it, is called the impulse momentum theory. And I want to write this down before we go on to the problem, because I don't want to forget that we did say this. Impulse momentum theory. Okay, the reason it's called that, Ft is a force over a time period. That's defined as an impulse. And if you go on to study engineering or science, you're going to look at this and you're going to hear impulse. It means something that causes some sort of like a jolt or a change. Okay? So this is the impulse, and this is momentum over here, so it's the impulse momentum theory.
Why is it just a theory?
Well, gravity is a theory also.
Because you can't prove it for a single number.
Yeah, it's not something that we are 100% sure. It's a theory of why things happen. We're pretty close to sure, you know what I mean?
Yeah.
But there's no like real formal proof of it, so theory.
Like gravity.
We can get there in a second, hold on.
Construction that well.
Oh, that's why your answer's not right, because you're units. That's why I'm going to stop you for a second. We'll go over that. KGMOR should be units.
Why would
Kilograms and then units per second.
One of the Indians.
All right, let's get back to the problem. So, we've got mass 1. That's the bullet, right? Mass 1. 4 grams. What should I convert that to?
0.004.
Okay? So start by converting that. Next, what else do I know? Good. Mass 2 is 6 kilograms. The thing is out of control. Velocity 2 is 8 meters per second.
Would you set an equation equal to each side then? Mass like 1 equals mass, you can do that.
You have the right idea, Max. Keep going with it.
do you can do
Maybe if we put like a flammable substance above the radiator, it would help us.
The reason this happens because the room wants to get warmer. The whole school session, we keep opening the windows. It doesn't. So we can open the door a little for relatively calm with our voices.
you can do M1 V1 equals sweet action.
I don't want to open any windows right now, only because that's constantly running because of the fact that it's not up to the temperatures the school wants. The thermostat is set for 74. The current temperature is like 70 in here. So because of the fact that it's not up to 74 yet, it's going to keep running in it. So if we open the window, that's going to keep happening all day. Now, Max mentioned, Max said a minute ago, we want to know what the velocity needs to be of the bullet so that they have the same momentum. So go ahead and do this. Start by writing. You want the same momentum. Momentum 1 equals momentum 2. That's what we're trying to do here. Again, the momentum of the first object, we want it to be the same as the momentum of the second object, so set them equal. Plug in your formulas. M1 V1 equals M2 V2. We're looking for V1. Okay, we're looking for V1. You could have done it by finding the momentum of 1, setting it equal to mv to the other, and then solving. Okay, you probably get the same answer. Now, if I want to get V1, which is my goal here, V1. Quickly, what do I do? You get V1? Yeah, divide by your M1. Guys, I don't know why we're not focused today. Let's go. Stop talking, stop the chatter, look up, stop staring at the ground or whatever you're looking at in your desks. Now, we want to find V1. So we get rid of the M1 by dividing both sides. That's our generic expression for the velocity. Now, just plug in your numbers. M2 is 6 kilograms. V2 is 8 meters per second. And M1 is 0.004 kilograms. What do you end up getting for this? Who's got a number? Raise your hand. Fernando. 12,000. And what are your units, Fernando? Just meters per second, because it's only velocity. It's only velocity. If you found the actual momentum, P, that would be kgm over s. And please, take a look at your units, everybody. Watch. Look right here. Kilogram cancels with kilogram. You're left with meters per second. That's all you have there. Okay? So this is a very basic example where we have the momentum of one object equal to the momentum of the other object. Does this not stay that way? No friction?
Look through my
Let's increase the normal force a little, so we increase the friction. That's the way it works, though. It's the truth. That's why I put the object on top of it, not next to it. Make sense? If I put it next to it, it might hold it. It might actually hold it by itself, Jim. I think it's strong enough. Yeah, it needs to stop. But next to it, it would be two separate frictional forces.
That's why I need doors.
Well, the door has inertia. It's currently at rest, so it's going to stay at rest. So when I move it, it wants to stay at rest.
Tinkelberg.
The hinge, though, is a little bit off, so it's causing it to open. All right, let's go to the second example now. One that's a little tougher. A 1,500 kilogram car moving. Remind me to talk about airbags after this example. Airbags, please. A 1,500 kilogram car moving with a velocity of 20 meters per second east. So a car is being driven to the east direction with a velocity of 20 meters per second. It collides with a tree. It comes to rest in 2 seconds. Now, these numbers are all realistic, by the way. I chose actual values. Okay, that actually represent a car, a velocity it might be moving at, and the time period it takes the car to stop if it is colliding with a pole or a tree. Find the force exerted on the car during the collision.
How fast is that? Is that like
20 meters per second?
is that like
I don't know off the top of my head.
I think
it
it's
was like
like-
60 or something. Hold
Yeah,
on.
back.
20 meters per second.
But once, doesn't it, if it hits
No
trees,
idea.
then it just like stop and like takes 2 seconds?
There's actually a time period in which it starts to crunch and then starts to rebound off a little bit.
and then like it like kind of
Oh,
bounces.
you count that?
Yeah, all that time while it's in contact is where that force is being pushed on the car.
This one's weird because you don't have any other things you need. Well, you do. You just have mass and velocity. I don't understand it.
And you have the time to
Yeah.
second.
It's 45 miles an hour.
Oh, okay.
Okay, that's what it was.
You define.
By the way, we all know how to do that. I mentioned. Make sure you use that if you want to convert on Google. All right, so let's list our givens. Mass is 1500. VI is
20 meters
VF is
0.
0. Why is it 0?
You stop and it comes.
Yeah, it comes to rest. And the time period is,
2 seconds.
and we are trying to find.
The 4
So right away, guys, right away. P equals mv is not going to do anything for you here, right?
Yeah, it is.
Because you need the force, you need the time. So we might use our second equation.
Wait, if you find P equals mv, then you have the momentum, then you can calculate the force.
Sure, you could always do that, but that's so much work. Use the momentum impulse theory. Go like this. Because now, take a look. You can find delta P. You know what T is. You can solve for F. Just do it all in one line, I'm saying. Okay? Yeah, the P definition helps us, but use the impulse momentum theory.
But you don't.
I can tell you why. And hold on for that question for a second. You're right. Hold on one second. Think about why.
F or P.
Think about what's happening.
How
The
do
tree
we
is
get
pushing
P
it back.
if you don't have that? Because yeah, we have to do another equation.
So we plug in for delta P. Delta P is mvf minus mvi. Again, the definition of momentum is mass times velocity. If I want to know what the change is, I do final minus initial. Final minus initial. What am I solving for here? So go ahead and divide everything by t. And that's our expression right there.
What units are
What is the final velocity, everybody? 0, right? So go ahead and do this. So you end up getting the solution for f in algebraic terms is negative mvi over t. Again, there was no final velocity because it comes to rest. So notice you only have negative mvi over time. And that's the solution for this specific equation, or this specific scenario. Does that make sense? The mvf is not always going to drop off. What do you get here, people?
30.
Negative.
I got negative 1500.
I got negative 15,000.
I had negative 15,000.
I got 1,015,000.
Count my zeros.
Jeff, tell us, Jeff, please. Why is this negative?
Oh, because the tree is pushing it backwards.
Yeah, the tree's pushing it backwards. I'm going east. Isn't that positive? If the tree wants to stop me, which way does it have to push? West. We consider west to be negative, so the force has got to be negative then. Okay, our answer makes sense. Makes sense of it.
S'more.
So, yeah, I did, n times 3, I got 30,000, I divided 30,000 by 2.
M times V divided by 2. Same thing.
Yeah. Which I don't understand the benefit of doing it that way. Oh, that's not momentum, that's mass.
Yeah, M stands for mass.
Yeah,
P is the momentum here, okay?
yeah, no, I just thought that was
Questions on this? Questions? Gentlemen in the back, we good? Can we look up so I can see some, acknowledgement of this? Thank you. I don't mind you discussing the question, but please answer my questions. Next one. Well, you know what, before we get this example, pause. I want to talk about airbags. slows you down. If you don't have airbags, what happens to you when you hit the windshield? Bam! Nail that windshield, right? Now, an airbag is deployed. Instead of you hitting the windshield, you hit this like mound of air, like a cloud almost, and your face kind of goes into the cloud of air, or the, container in a sense, and it slows you down over a certain time period. And here's what you think about. Watch what happens here. If I can actually move this down. Look at our answer we got. It was 15,000. That was the force that we feel from the car hitting into the tree. That's a lot of force, isn't it? Now imagine you have an airbag in your car, and instead of 2 seconds of maybe contact, now the time of contact is 4 seconds. If you make this a 4, what happens to your answer? I know it's not really 4.
It's gonna get a lot smaller.
It gets a lot smaller, by a factor of 2 really. So if you can increase the time interval in which you are in contact with the airbag, you feel less force. And think about it. Make this number like a 10. If this number is a 10, now this force is only negative 3,000 newtons. So look at the difference. Instead of feeling 15,000 newtons, now you're only feeling 3,000 newtons because you can increase the time interval. It's the same thing as a trampoline. A trampoline absorbs your shock, right? When you hit the trampoline, don't you take 2 or 3, or maybe less than that, 1 or 2 seconds to slow down? Imagine if you're on a trampoline and you jump off and you land on the ground. Don't you feel that jolt on your legs? Kind of hurts a little bit if you don't actually bend your knees as you land. Same idea. The trampoline absorbs the shock. So we're going to do later this year, keep this in mind, we're going to do an egg drop experiment.
Yeah.
We have to build a container for an egg drop. And the idea there is the same thing. You want it to absorb the shock, right? So you don't want the egg to slam onto the ground. If I toss Stash an egg, Stash, how would you catch the egg if I just tossed it to you? What would you do? Yes, you would do this, or you would gradually catch it. Like in baseball, if you throw somebody a ball long distance, you can catch it. It's not hard. You just got to go like this. It's called soft hands. Have you heard that? Soft hands. Okay, I need you accept.
Yeah, I got hard hands.
So instead of hitting your hand and having an instant contact, it is slowly contact. So your time interval goes up, and this makes your force go down. So write this down, please. As the time interval of contact goes up, the force felt goes down. They are inversely related. And that comes about from this equation right here. Again, take a look right here, everyone. This is the equation you want to look at here, or even right here, you can look at this line. The force and the time, they're in opposite spots, numerator and denominator of the sides. So they are inversely related to each other. So as time goes up, the force felt goes down. I saw some hands over here. Kinetic friction. Kinetic friction. We're good.
Oh yeah, because the static
Thank you.
friction, the force pushing the door was more than the static friction, so it changed its weight.
Exactly. Exactly.
I saw this video on YouTube.
Uh-huh.
Wait, I saw this video on YouTube, and these engineers put they put 2 airbags under their friend's air mattress. And
I've seen it.
when he went to go way down, he smacked himself up on the ceiling. He was knocked
That's really
unconscious.
funny.
I saw one of that and the guy died. Yeah. It was also pretty tough. He was really
Oh,
old.
what's that?
Sort of.
Yeah.
How does the time change? How do you
If you didn't have the airbag there, the time of contact between your face and the dashboard would be 0.1 second. Okay? If you have the airbag there, it slows you down. The time of contact.
Switch your face,
So you're
not the car.
gradually slowing down. Well, this is the force felt by the car, which would transfer into you, really.
Yeah.
Right? If you think about it?
Yeah.
Okay, so what you're doing is you're increasing the time in which it takes you to slow down, so you don't feel that force right away. Okay? It's the same idea. If I stood on this desk and jumped off, would I lock my legs or would I go like this?
Like that.
Like that.
I would bend my knees as I landed, wouldn't I? To absorb the shock. The reason is, if I lock my knees and land, the impact is over 0.1 seconds. But if I land and I do this, now the impact took maybe a second or 2. So you increase the time
Jump
there.
off the desk and go off your knees. That hurts so
I'll
bad.
do it.
No, I would never do it. It's not fun at all. Yes.
Wait, to make this more interesting,
Mhm.
maybe we watch Jackass and then there's just a lot of
Instead of
stuff.
physics behind it,
Yeah, no, instead of physics.
if you can find a version that is not the same rating, sure, but obviously no.
I thought this one where you
If there's
you
like
inhale
a-
the thing
if
of
there's like a
alcohol
censored
through his
version of it?
anus.
Yeah, no, there
We
is.
could do that.
No,
Sleep
the one
out.
where the hand
Just the one with the
Maybe
thing where it goes up in the air.
Oh my god.
There's a fish.
Because it's exerting a force up.
As long as it's censored, I don't mind, but bring it up to my attention.
Steve-O put a fish hook through his cheek and then jumped into the shark and
Try and find
kissed
something
the
like that. You know what else?
Yeah, they towed him from the speedboat.
Other questions? Jack? Yeah, so airbags, as much as they help people, they can hurt you because there's several reasons.
When you get chased by the police, you can take your airbags.
I was in the front seat when I was a second.
People, you can get burned, first of all. There's like a chemical that's on the outside of it that if you hit the airbag and your skin rubs across it, you can get a burn from it. They're actual burn marks. But for the most part, the effect of the airbag and whatever it does to you as a side effect is much more welcoming than dying and hitting your head on the dashboard. Now, if you're a child and you're in the front seat when you shouldn't be, and there's airbags there, that could easily kill a child, yeah. Because there is a lot of force on it still. There still is. So it's like they're making a disclaimer by doing that. Yeah, so it has happened.
I saw this picture of this guy who was in a car accident, and he was driving the car and the airbag deployed, and he got an imprint of the Audi logo in his arm from the hood, like the thing on the steering wheel. The
little
the
decal.
emblem on the,
Yeah.
on the steering
It's
wheel threw out and hit him so hard the thing he had like a permanent scar.
Wait,
The Audi
through the
logo.
airbag?
I don't know, something happened.
Oh, because the top of the thing pops off
Yeah,
and the airbag
exactly.
comes
Yeah,
out.
and it just
So
it
that
hit him
little
so
piece-
hard in the arm that he
That's
had
funny.
like a permanent Audi logo.
They have like airbags now that have like holes, like so oxygen can get so like if you're less alive, you're supposed to be getting some stuff too.
Is that right?
Yeah.
I've never seen that. Is it new?
Yeah, because like some like I think it's like if you're under a certain height and the airbag hits you, it
It might suffocate you and
yeah,
like
like
keep you under?
there's like lots of like
Imagine that, dying by suffocation with an airbag?
yeah,
It's a bad way to go.
yeah. So like they have like now they're making the new cars with like holes in the airbags and like, the oxygen.
So that you can actually still breathe when it hits you?
Yeah.
Let's write down the next problem, please. Guys, these things that I talk about, like airbags or jumping off the table and like bending your knees when you land or a trampoline, these are the kind of questions you're going to see for those middle questions, where it's like a short answer. I'll say like, explain why when you jump off a desk you want to bend your knees. So you lower the impact, you lower the force because the time interval goes up. Or why are airbags useful? Well, because the time interval goes up, so the force goes down, so you don't feel the impact as much. These are the kind of questions you're going to see in your test. Okay? A half a kilogram soccer ball moving to the right with a velocity of 9 meters per second bounces off a wall. Okay, so you kick a soccer ball, it hits the wall, and it bounces off. So far, so good?
From the window.
The wall exerts a force of 4.25 newtons on the ball for a time period of 2 seconds. Determine the velocity of the ball after it hits the wall. So you hit the ball with a certain velocity, it's going to come back at you. You want to find out the velocity on the way back. So what should our answer be automatically? What sign? What kind of number? Negative, right? Because it's coming back to you now. You kick to east, which is positive, or to the right, so it's going to come back with a negative. So our answer needs to be negative. So that's an automatic sanity check in the beginning of the problem. If you don't get a negative answer, something went wrong along the way. Let's list our givens. Mass is a half kilogram. It's very own. And I calibrate it every day and it still does it. One day.
One
You should have done a better spot.
Now here's the big key. If I kick a soccer ball into that wall right there, which way does the wall push? Does it push this way or that way? This way, right? Yeah. Not the angled wall, obviously. Say the cabinet. So it pushes back. So what sign should the force have on it?
Negative.
Negative. Negative. You guys not eat breakfast? I always eat like something on the ride on the train.
I got me some eggs and toast.
That's deep.
You
I
know what?
ate a baby.
What do you want?
I got something in my eye.
I got something in both my eyes.
Do they offer breakfast during like activities period and stuff?
Yeah.
Yeah.
So during first period you can still get
The
breakfast?
first period, I think they do, yeah.
Their eggs are like neon though, like.
No, because like, you know when like you make it in like a, for like a large group, like you use like a powder? Like at like camps in school, I don't think they do that.
Here, man, yeah. I'm pretty
Yeah,
sure
but
they
they
do
do that in some places, but they look interesting.
They look different than when they make it for the like bacon, egg, and cheeses.
Bacon, egg, and cheese. Bacon, egg, and cheese.
If you ask them for like scrambled on bacon, egg, and cheese, it's completely different than when they make it in like bulk.
Yeah, because like when they make it like
Said when I
bacon, egg, and cheese.
scrambled egg.
So you're saying individual sandwich scrambled is different than the bulk one?
0.058 meters per
That's
second.
why I said scrambled for bacon, egg, and cheese and
Sorry. All right, let's go to our equations.
Looking for final velocity.
We've got
Yeah, oh yeah, that makes sense.
start with our equation of impulse momentum.
Oh, that's not bad.
Let's go, guys. Come on. We want to figure out what the velocity is of the ball after it hits the wall. So let's fill in. We've got F T equals mvf minus mvi. Again, the change momentum, the final momentum, mvf, minus the initial momentum, mvi. We want to find vf, so let's move the mvi over. Okay, again, we're trying to find vf, so move the mvi over by adding it, and then divide by m.
Alright, so let's say that you did T equals F times T. So that's the equation. No.
No.
The m's can cancel over here, but they're not going to cancel there.
Oh,
Why are you trying to find new ways to do it? Now, I have no problem with that, but
Oh,
this is
no,
like
no.
an easy way to do it.
I really don't. I don't know what's with that I don't get. Like that equation. So I did P
That
equals
made
F
so
times
much
T,
sense.
and then I got P equals M over G. Yeah.
P is not equal to m over here.
Yes, it is. No.
Max.
Max, just try and stick with this equation for now. Just to make, no, don't put a sleep. Try and stick with this equation for now, Max, please. I encourage the different thought, but this just makes it easier. You're doing more work than you need to. Now, at this point in time, everything is known. So just plug in. We've got a force of negative 4.25. A time period of 2 seconds. A mass of 0.5. An initial velocity of 9 meters per second.
17.
All over a mass
17.
of 0.5. Okay, again, so we're just plugging in. What do we get for this?
17.
Negative 93. Yeah, negative 93. I got negative 8.
I got
Do your numerator first. Do your numerator first.
17.
Okay? The numerator is going to become negative 4, and then when you divide by 0.5, you get negative 8. Tonight, here's what I want you to do.
Sorry, guys. It's okay.
Tonight, please, we're gonna do 2 more examples still tomorrow, just so you know. But tonight, begin the section of homework. There's a lot of problems here for the homework. Try the first ones. So page 209, numbers 2 and 3, and page 211, numbers 1 and 3.
Like, why is there talking?
Okay? Again, 209, numbers 2 and 3, 211, 1 and 3. There's 2 more sections, or 2 more parts of the homework over the weekend. Get this done, gentlemen, get this done tonight, not over the weekend. Please don't forget, guys, your prom sets are due on Monday. If everybody, listen carefully, the other class asked this. If everybody turns in their assignment on time,